Good day, class. We're going to continue on with some logarithmic stuff today. We're going to talk about the change of base formula and some more properties of logarithms. All right, so the change of base formula. All right, now do remember that I always like to use my base being b. So I would make this b, this b, this b, and this b. Right, if you have some other base other than 10 or e, which are what the buttons in our calculator use, all right, then we can go ahead and use these formulas. All right, so if we have log of some base b of x, we can simply use our log base 10 button in our calculator by saying log x divided by log b, or you can use the ln as well. Either way is going to work just fine. All right, so if we want to use a calculator to evaluate this, all right, remember here it says we take the log of our argument divided by the log of our base, all right? So here we could say, all right, log of 16 divided by log of 3, all right? And if we go ahead and do that, all right, we get 2.524. All right, so we can do that with all of these, right? Here we could say log of 22 divided by log of 5. At 1.921. All right, however, all right, back in the day before calculators got super fancy, this is kind of how you had to do this. All right, but now there's actually another way. You can actually hit math, and you can just hit up a few times until you see this log base command. All right, then it kind of allows you to input your base and your argument. So if I wanted to do log base 3 of 16, right, as you can see, we get the exact same answer as what we used up here when we used that change of base. All right, so if we wanted to do here, we could say log base 3 of 209, right, 4.863. And then, of course, log base 12 of 0.1. Negative 0.927. All right, so change of base formula or the log base command in your calculator either work quite nicely. Okay, so now we're going to talk about some properties of logarithms. These are used to condense and expand logarithms. All right, the product property says that if you have log, and then your argument is, and this can be of base b, and your argument is a product of two things, so maybe m times n. That can be broken up as log base b of m plus log base b of n. Quotient property works the same way, but with division and subtraction. So if you have log base b of m divided by n, you can rewrite that as log base b of m minus log base b of n. And the power property says if you have some log of base b with some m raised to the nth power, that you can actually bring this exponent out in front as a multiplier, and that's the same thing as n times log base b of m, right? And we'll be going back and forth both ways with these. If we're trying to expand, we go from the left side to the right side. If we're trying to condense, we go from the right side to the left side. So you'll want to have these written down somewhere handy. Right, write each logarithm in terms of ln2, ln5, or ln3. Right, so using the properties we just wrote down, we can kind of rewrite 10 as 5 times 2. So then, of course, we can use our product property to say, all right, well, this is ln of 5 plus ln of 2. All right, you may want to pause it here, try these out on your own, and then hit play to see if you worked them out correctly. All right, this one is very easy, works just like this first one, except now we can have 3 times 2, so ln of 3 plus ln of 2. All right, here we have division, but we also don't, like this bottom one isn't, 2, 5, or 3. So first, I'm just going to keep this as 5 over, well, 32 is actually 2 to the 5th power. So now I can rewrite that as ln of 5 minus ln of 2 to the 5th. All right, well, and now I can use my power property to move this exponent out front. So I can rewrite this as ln of 5 minus 5 times ln of 2. So now it's in terms of just only these things. All right, so we're good to go. This will work very similar here. All right, 27 is, of course, 3 cubed. All right, so I can take this, move it out in front as a multiplier, and this becomes 3 times ln of 3. So now these are all written only in terms of ln2, ln5, or ln3. All right, use the properties of logarithms to verify this, and verify these things. All right, and this actually should be, this is different. This should be 2, I believe. All right, so here, all right, when you're verifying, all right, all you do is start with one side of the equation and make sure that you get to the other, okay? So here, I'm going to start with log base 7 of the 5th root of 7. Now remember, we talked yesterday about fractional exponents and that kind of stuff. I can actually write the 5th root of 7 as 7 to the 1/5 power. Well, now I can use my power property to bring this exponent out in front as a multiplier. All right, and one of our properties that we talked about yesterday, all right, we said if log base b of b, we said that that equals 1. So this whole thing is equal to 1. Well, 1/5 times 1 is just 1/5. Since I started with one side of the equation and I got to the other, I verified it. Basically, verifying gives you the answer. You just have to show how to get there. All right, same thing here. All right, I'm actually going to, this is the same thing as -1. So I'm going to bring this up as an exponent here. And this will give me log base 10 of 1 over 100 to the -1st power. That essentially just flips the fraction here. So this is really log base 10 of 100. Okay, well, 10 to what power equals 100? If you think about this in exponential form, using our definition of logarithm yesterday. All right, well, that just equals 2. 10 to the 2nd power equals 100. So since we started here and we got here, check. We verified. All right, use the properties of logs to expand each expression. All right, so now these are all being multiplied. So I can rewrite this as log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Right, these three things were all being multiplied, so I can rewrite them separately with addition. Of course, now I can take this exponent and bring it out front as a multiplier. So I will have log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So now this is fully expanded. I'm done. Here we have things being divided, so I can separate them with subtraction. Also, do remember that a square root is just that thing raised to the 1/2 power. So again, I can take this exponent and bring it out in front as a multiplier. And we are fully expanded. All right, now we will condense. So now we're given it expanded and we want to condense it, make it nice and clean. All right, so I can take this and move it as an exponent. So log of x to the 1/3 power. All right, and then plus log of x minus 5. And I can bring this out in front as an exponent here. All right, now remember, being raised to the 1/3 power is the same thing as the cubed root. So now, since these are plus, I can condense them to a single log and simply multiply my arguments. So this will be log of the cubed root of x times x minus 5 to the 5th. And we're done. All right, similarly here. All right, we can have, this will be ln. And I'm just going to do this in one fell swoop. All right, so we'll have x minus 4 to the 4th power up top. Because of this subtraction, I divide, and I'm going to have x squared in the bottom. Again, I can take these numbers out front and make them exponents here. All right, and that's it. We're done. We're condensed. All right, here, because of this plus, I can multiply my arguments. And then because of this 1/5, all right, I'm going to basically take the 5th root of everything. All right, so this is going to end up being log base 3 of the 5th root of x times x minus 2. You could do that in more steps if you needed. All right, it's perfectly fine to kind of break it down step by step like I did here, but once you see them enough, you'll just kind of be able to jump straight to the answer. All right, show that each expression is equivalent to ln of 8. All right, I'm not going to worry about these for time purposes. All right, so 3 ln of 2. This is the same thing as ln of 2 cubed, because I can bring this up as an exponent. And 2 cubed, of course, is 8. All right, here I can do similar. This is ln of 1/8 to the negative 1st power. All right, of course, that's the same thing as ln of 8. Here, similarly, we will say ln of 1/2 to the negative 3rd power, which is, of course, the same thing as ln of 8. Here, we use our quotient property. We say this is the ln of 16 over 2. Of course, 16 over 2 is 8. All right, this is the only difficult one. All right, so here we're going to have, and remember, log base 10 is just log. So this is log of 2 times 4 is 8 over log of e. All right, now at the very beginning, we talked about the change of base formula, and we said that log base b of a is equal to log of a over log of b. So this is my log of b, this is my log of a, so I can actually rewrite this as log base e of 8, right? All I did was use that here. And of course, log base e is ln. So we are done there. All right, of course, your assignment will be on Delta Math, and that is it for today.